All right, so today we are going to start an activity that we're going to get into today, and we will finish tomorrow. And we kind of modified it so everybody at home can also partake in this fun. But so the first thing we are going to start with is we are going to start with atomic structure bell work number 1. So if you want to have your notes out, you can. But I would like for you to take a moment and say, what is Z? What is A? How do I find neutrons? Can you change the number of protons in an atom? If you cannot, how do we get a positive charge? Then I would like for you to fill out the bottom here. Remember, the top 16 is the mass. 8 is the atomic number. And the number up into the back is the charge. So I'm going to see if we can't give you a few moments here. Those of you at home as well, you want to do this because it's actually, this is the lecture questions for today. And so everybody should get it perfect because we're all going to do it together here. So do this first, and then I'll just have you put it in. So I'm going to give you a few minutes while I take some attendance. You are filling in atomic structure bell work number 1 from yesterday's notes. All right. See a lot of people rolling along, doing pretty darn well here. So let's get into it. Make sure everybody understands what's going on here. All right. Z. Z is the first thing we learned yesterday. That is the atomic number, or you can think of it as the number of protons. A is the atomic mass, or the number of protons and neutrons. In order to find mass, you just take the difference of those two things. Atomic mass minus atomic number. So that's just A minus Z gives you newts. Okay. Can you change the number of protons in an atom? No, you may not. So in order to get a positive atom, you have to lose electrons. Okay. Remember, in our full atomic symbol, you put the symbol there, whatever it's like HE or O or P or whatever. The mass, A is at the top, Z is at the bottom, and then the charge is up to the superscript after the symbol. Okay, so if we're looking here, the bottom number always tells you the number of protons. So beryllium has 4 protons. Copper has 29 protons. So the bottom number always tells you the number of protons. Then you can kind of go whatever order you would like. I think it's easy. Okay, the reason why they set it up, A over Z, is, again, we said A minus Z gives you neutrons. So you just do a subtraction problem. So if I want neutrons, 16 minus 8 just simply gives me 8 neutrons. 9 minus 4 gives me 5 neutrons. Okay. Wonderful. Then to figure out electrons are a little bit more challenging. I would like a -2 charge on this oxygen. So that means I need 2 extra negatives. Remember, electrons are negative, protons are positive. So if I'm +8, how many minuses do I need to be to end up with an extra 2 negatives? 10. Okay. Awesome. This one, however, wants to be a +2. So if I have 4 plus, how many do I take away in order to end up with a +2? You can only take away 2. +4 minus 2 still leaves me with a +2 charge. 64 minus 29 gives me 35. If I have a neutral charge, that means they're exactly the same. Awesome. So again, the number on the bottom, 13, tells me the number of protons. 27 minus 13 gives me the number of neutrons, and the order of these will change so that you know what you're doing. You got to make sure you're reading. It's not just always going to be minus these, does the bottom one. And then if I want to be a +3, I have 13 pluses. That means I can have 10 minuses in order to get my +3 charge. Chlorine -1 here. Chlorine -1 here. 17 protons. 35 minus 17 gives me 18. If I want to be a -1, that means I need one extra negative electron. That's looking at 18. What I want you to do right now is I'd like for you to open your Chromebook. This is actually, I put this exact same thing in for today's lecture questions. So why don't you take a moment, go ahead and knock that out. If you have not done yesterday's lecture questions, why don't you do that as well? Beautiful. Okay, so you're working on putting this information up into, I can show you, atoms, ions, and isotopes lecture questions. You are just going to take the information that we did and you're going to plug it on into here. Okay, so I'm going to give you a few moments to do that as well. Put the music on quietly. Come around, see if you have any questions. Check in. I see a few more new people here. Okay, so what we used to do was we had these little stations, we had these little petri dishes, and these were representative of atoms. Like if you could see an atom, it has a little nucleus in it. It has electrons flying around it. So this was supposed to represent an atom, an ion, or a set of isotopes. And then students would walk around with their packet, count them, and then fill in some information. We obviously can't have you guys huddled around these, counting these, breathing on these. We can't sanitize these. So we kind of made it into a digital presentation coming at you. So this is an activity that we would normally do. It's just going to look a little bit different because you're going to have to do it in your seats, unfortunately. So the first thing we're going to do is we're going to go through is we're going to talk about ions and add the difference between atoms and ions. So thinking back, protons have a positive charge, correct? Electrons have a negative charge. And neutrons have a 0 or a neutral charge. We're all feeling good with that. That was a refresher from yesterday. An ion is a charged particle. In order to become charged, you must gain or lose electrons. The name of a positive ion is called a cation, and a negative one is called an anion. So they're kind of just refreshing. So what they have, or what we have done, is we've compared a lithium atom and a lithium ion. So you do need your periodic table for this bad boy. Find yourself lithium, little Li. How many protons are in lithium? 3, thank you. Okay, now that is never going to change. So sometimes I just say, I don't care if you're an ion, an isotope, whatever. If you are lithium, you will always have 3. Now, an atom is neutrally charged. So what I'm going to do is just as an atom. So I'm just going to write down here the charge is going to be 0. And this ion tells me the charge is going to be +1. Now, if you've not been given any information about the mass, you can just simply use the mass off of the periodic table. So what is your mass rounded for a lithium atom or ion off the periodic table? 6.94 will round to a mass of 7. What 2 things are involved in the mass? The protons and the neutrons. So what must the number of neutrons be in order to add up to 7? Talk to me. You got it. Okay. Then, in order to get a charge of 0, remember protons are positive, electrons are negative. How many electrons must I have here? In order to be a charge of 0, you're looking at 3. Easy. Let's draw it. So what we're going to do down here, here's your nucleus. So I'm going to do 3 protons. 1, 2, 3 protons. 1, 2, 3, 4 neutrons. And then we have 3 electrons. 1, 2, 3 electrons. That is what a lithium atom with a mass of 7 would look like. Then all it's trying to get you to do is to compare what would change in a lithium +1 ion. We said the number of protons never change. Would doing anything to the neutrons affect the charge? No, because they're neutral. So all we're going to do is we're going to keep it the same. Still has a mass of 4. However, how many electrons must I have in order to end up with a +1 charge over here? Got to have perfect. Got to have 2. Because now I'm +3 minus 2 leaves me with a +1. I want to show you another way you can do the nucleus because it will get very annoying to draw all of them. If you would like, you can say, how many of these guys do I have? I got 3 of them. How many neutral ones do I have? I have 4 of them. And then if you want, if you don't want to draw every single thing, you can also write it like that. So, but the idea is that when you went from the lithium atom to the lithium ion, you've lost yourself 1 electron. Okay? So there is another one, except for it's going to make you negative, but you can do that. Stop it. You can do that one on your own. So I did one example for you. There's fluorine you're going to show with me. So let's go to the inside, if you don't mind. I know everybody wants to just finish the worksheet. Yeah, so go to the inside. I want to do one example on the inside with you. One example on the inside. This is now on the inside going to compare isotopes of each other. So remember, protons have a mass of 1, electrons have a mass of 0, neutrons have a mass of 1. Perfect. An isotope is 2 of the same element with a different mass, 2 of the same element with a different mass because of a different number of neutrons. Awesome. All right. So what they're going to have you compare is carbon-12 and carbon-14. Comparing carbon-12 and carbon-14. So finding they're obviously isotopes of each other. We're going to find our periodic table. We're going to locate carbon. How many protons does carbon have? 6, no matter what. This, remember in the full atomic symbol, this number up to the front tells me the mass of this carbon is going to be 12. The number up to the front here tells me the mass of this carbon happens to be 14. So all I want you to tell me is what makes them different. Okay. I know that these 2 numbers, protons and neutrons, have to add up to 12. So what's going to be my number of neutrons here? 6. Then, if you have no reason to think it's charged at all, you can go ahead and leave it neutral. Gives you a weird number. Okay, but if I have 6 protons, I'm also going to have 6 electrons to make it neutral. Okay. All it wants you to do is then compare, and so you can do the same thing. 6 pluses, 6 neutrals, 6 electrons. Awesome. So what's going to change in this isotope? Well, it has a mass of 14, but I know I still have to have 6 protons. I can never change that. I'm never going to change the electrons because it's still going to be neutral. However, how many neutrons does this carbon have carrying around in order to get him to a mass of 14? He has 8. Okay, so then you're going to draw the difference here. Where did the difference reside? It resided in the nucleus and all that kind of good stuff. Okay, awesome. So I know you can do the other one as well. I'm going to show you how to do the next portion, and then I'm going to leave you alone to work the rest of the period. So what you would normally do is you would then come up to a station and you would take a look at an actual, and this is a terrible picture, we made it better online. You would come up to a petri dish here and you would count protons, neutrons, electrons. You would tell me what it is it an ion? Is it an isotope of something else? We can't do that. We can't have you guys up around the room and doing all that stuff. So what we have instead, if you go into Schoology, into the Tuesday folder, All right. Into the Tuesday folder. It says atoms, ions, and isotopes activity slides. What you're going to do, where it said, well, that's really big. I need to be able to flip back and forth. Stop it. Exit, exit. How do I get on the slides? There we go. Okay. What you guys are going to do is you're going to go to station 1 on your slides, and we're going to count how many protons are in station 1. So let's count the red beads. 1, 2, 3, 4, 5, 6, 7 red beads, correct? So you're going to go to your little chart, and you're going to say 7 red beads. Let's count how many neutrons. 1, 2, 3, 4, 5, 6, 7. They're not always equal, but it happens to be here. 7 neutrons. The electrons are the green ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. 10 electrons. So you can do this 2 ways. You can grab all the data first and then sit down and process it, or you can go and process it as you go along. But the idea here is how would you figure out the mass number? We know the only 2 things that have mass are the protons and neutrons. So if you want to put a box around these, those tell you the mass number. So 7 and 7 is going to give me 14. How do you know what element it is? You don't ever look at the mass number. You look at the number of protons. Protons tell you what element it is. Remember, that's its identity. What element has 7 protons? Nitrogen. Very good. What is the symbol for nitrogen? N. Okay, so you do need your periodic table out with this. Remember, for the full atomic symbol, if you want to kind of jot it off to the side here, you write the element symbol, you write the mass, you write the atomic number, and you write the charge. So this would say, oh, hold on. 14 and 7. The hardest part will be trying to get the charge. Let's talk about the charge. If I have 7 pluses and 10 minuses, I have extra negatives, correct? I have extra negative electrons. How many extra negative electrons do I have? I have 3 extra negative electrons. So that means I am negative by 3. Okay? So all you're going to do is you can finish the front page and a half if you would like. The slide deck is there. Then what you're going to do is you're going to go to the next station, quote unquote, and it's going to be another one. And so you're going to count how many protons, how many neutrons, how many electrons, figure out what element it is. Then there are some post-lab questions asking you which one represents isotopes. Remember, they have to be in pairs. Which ones represent ions? Which ones represent any atoms? Remember what an atom is. And so all that kind of good stuff. So you're going to start working on this today. You got about a little over 15 minutes to work on this, start to get that chart filled out. And we will have time to finish this tomorrow. I want to walk around the room, see if anybody has questions here. Then I'm going to come and I'm going to talk to everybody at home. So don't go anywhere. You guys are just filling in the chart. And like I said, if you want to just count and like get this whole information done and start with your counting, that's awesome. And then you can fill it in whatever you want to do. Okay. Awesome. Jams on. Jams on.